In 1895, Guglielmo Marconi invented the radio and subsequently changed the way that humans search for life in the universe forever. The ability of radio waves to travel at the speed of light through space with ease quickly gave birth to the concept of SETI. SETI refers to the search for extraterrestrial intelligence and is concerned with seeking clear and conclusive evidence of technologically advanced life. SETI really gained momentum with the help of astronomer Frank Drake, a man often regarded as the father of modern-day SETI. Drake was one of the earliest astronomers to conduct SETI experiments, most notably his Project OSMA, the first organized SETI conference which inspired other SETI projects, including a brief NASA SETI project and many international SETI operations. Drake famously came up with an equation to determine how many civilizations in our galaxy we could potentially get a signal from. In the equation, N stands for the number of transmitting civilizations in our galaxy, R equals the galactic birth rate of stars suitable for supporting life per year, F sub planet equals the fraction of such stars having planets, N sub E equals the number of planets per solar system that have an environment that can support life, F sub life equals the fraction of such planets on which life actually evolved, F sub intel equals the fraction of inhabited worlds that develop intelligent life, F sub civ equals the fraction of planets having intelligent beings that produce a civilization capable of interstellar communication. And L equals the lifetime over which such civilizations are broadcasting signals. This may seem like there is an extremely small chance of finding other transmitting civilizations. However, the galaxy is a very large place, and the odds are still pretty good. One of the modern forms of SETI is decoding signals from possible extraterrestrial civilizations. Alien signals could fall into three categories. The first is signals being used for terrestrial communication, which is typically eliminated from being a viable form of SETI due to the relative weakness of terrestrial signals. Our television signals could only be intercepted at 1 light-year away, and the nearest star is over 4 light-years away, so it is unlikely that we would randomly intercept such signals. The second category is signals being used by a civilization's homeworld to another site such as a colony or spacecraft, which is also usually eliminated from SETI searches because those signals would also be comparatively weak to what we would need to reach other worlds. The final category is signals intentionally broadcast as beacons to contact other intelligent life forms. This one is considered most feasible. If extraterrestrials were to broadcast a strong, narrow-band signal over radio waves, we could intercept it and pick it out as artificially created, since natural radio wave emissions have comparatively large bandwidths. Any such signal would also have to be repetitive and consistent, since this would be the only way an alien civilization would be sure we would get it. If we were to ever intercept an actual alien transmission, it would also need to be decoded. One possible method of decoding is using prime numbers to form pictures, something we did in 1974 using the Arecibo radio telescope in Puerto Rico. The message we sent out was only 3 minutes long and depicted a human, a DNA structure, digits 1 through 10, and atomic numbers of common elements. The brevity of the message, coupled with the fact that it was aimed at a cosmic cluster M13, which is 25,000 light-years away, means that the likelihood of anything intercepting, much less decoding it, is very slim. And even if an alien civilization got the message, it would be 50,000 years before we would get a reply. It is generally agreed upon that humans, being such a young species on a young planet with even younger technology, should focus on attempting to intercept other beings' signals, rather than sending out our own. Radio SETI is one of the ways we attempt to intercept such signals. Using large radio antennae to try and pick up any incoming cosmic signals sent forth by alien civilizations, the signals are processed and searched for anomalies. Radio SETI searches are conducted either through targeted searching, where a radio telescope is pointed in a specific direction, usually a specific star, or through sky surveys, where a radio telescope is swept across the heavens to study a large portion of the sky. Due to limited funding and high research costs, modern-day radio SETI research is sometimes conducted while piggybacking on telescopes that are being used for other astronomical research. Radio SETI is additionally limited by the growing interference of radar, orbiting satellites, aircrafts, and other things. SETI researchers have described techniques to sort out terrestrial signals from extraterrestrial signals. However, as we become more technologically advanced every year, the terrestrial noise interfering with the SETI research worsens. There are a few main radio SETI projects going on today. The Intergalactic Plane Survey is being conducted by the SETI Institute using the Allen Telescope Array and began searching Kepler planets for signals in 2011. UC Berkeley is conducting the SETI Project Serendip using the Arecibo Radio Telescope. And SETI Italia is currently piggybacking on radio astronomy projects underway using the Medicina Radio Telescope. Since radio waves are just a form of light, it would also make sense that if we are looking for evidence of extraterrestrial intelligence, we might also monitor for visible or other forms of light. This is referred to as optical SETI. One of the reasons the use of optical SETI by intelligent extraterrestrials has been deemed unlikely is the fact that transmitting visible light requires a lot more energy than transmitting radio waves. Additionally, cosmic dust can create issues when sending visible light throughout the universe, since the tiny particles that make up the clouds tend to absorb visible light. Infrared light, however, is able to penetrate the interstellar dust, which would put optical SETI back on the map. Other issues with optical SETI include the likelihood that a continuous beam shined at a distant star could get lost in the glare of the sunlight of the transmitter's home sun, and the fact that the light is more difficult to convey decodable information through. If the distant civilization is sending small bursts of light at us, they would most likely need to be sent out every several dozen hours for us to potentially capture one. Modern-day optical SETI researchers are passively monitoring nearby stars to look for any of these potential pulse trains using photomultiplier tubes affixed to conventional mirrored telescopes. The Lick Observatory carried out such an experiment, as well as researchers at Harvard University. The final and most controversial form of modern-day SETI is searching for artifacts. This form of SETI is based solely on the chance that not only do extraterrestrial beings exist, but that they have already visited our solar system, and that they have left behind distinguishable traces of their time here. This may seem like a far-fetched idea, but artifacts, in terms of SETI, is less along the lines of UFOs, which do not meet the scientific standards of SETI, but more along the lines of popular science fiction movie 2001: A Space Odyssey, where aliens left an artifact on the moon for humans to find once they were technologically advanced enough. It has been suggested that intelligent life forms, if they were advanced enough to make it here, would leave behind something to be found once humans were advanced enough to reach it. Some people have particularly pushed for a hard look at the Lagrange point of the Earth-Moon system, 5 points in space where the effects of gravity from the Earth and the Moon cancel so that if you floated weightlessly at one of the points, you wouldn't be tugged towards either body. These have already been glanced over a couple of times and nothing has been found, but a more in-depth look could yield interesting results. Even if extraterrestrials haven't left any physical artifacts for humankind, their presence in our solar system could still be distinguishable in other ways. The kind of spacecraft needed to get from other habitable worlds to ours would need engines most likely powered by nuclear fission or fusion, or matter-to-antimatter drives. Such engines would leave signs of their operation that could be detectable up to thousands of light years away. Another way we could see artifacts of the existence of alien life is through tremendous feats of astroengineering. One form of this might be a Dyson sphere, an artificially created shell around a solar system with solar cells on the inside to keep the center star's energy from escaping as quickly, allowing the civilizations to harness an extreme amount of energy. The Dyson sphere itself would be undetectable, however, it would emit infrared light, which we could detect with our telescopes. However, we have had no such luck finding any of these yet. Though all of these attempts to search for extraterrestrial life might seem like they're not going to yield results, or are too based on chance, or take too long, they are still attempts. Every attempt increases our chances of finding the existence of extraterrestrial life. Humanity will continue to search as long as we are able due to our resistance to feeling alone. And it is easy to feel alone. However, the galaxy is big, and the universe is even bigger. And the likelihood that we are all alone in the universe on our little rock is extremely small. So we'll keep searching.